Okay, yesterday we looked at eliminating what I call some of the easy equations. Today we're going to continue on with elimination, but you're going to see more difficult equations. So just like before, this is a system of equations. You really have the option of solving by graphing, by substitution, or by elimination. So we're practicing elimination today. So the first thing you want to make sure is that your equations are in standard form. And really what that means is, do I have my x's lined up? Do I have my y's lined up equal to my numbers? And I do in this case. So if I were to add these two equations right now, nothing would eliminate. But you have a few options. Either you could eliminate the x's or you could eliminate the y's. And there's not a right answer. So I'm just going to eliminate the x's. So the first equation, I'm actually just going to leave as is. I'm going to leave as 6x plus y equals 6. Now the second equation, I notice that right here I have a 3x. And if I could get that to a negative 6x, then my x values would actually eliminate. Well, how could I get that negative, or that 3x to a negative 6x? I could actually multiply everything by a negative 2. So that's exactly what I'm going to do. I can do whatever I want to an equation as long as I do it to both sides. So if I multiply everything by negative 2, that second equation becomes negative 6x minus 4y equals a negative 18. Now I'm ready to add the two equations together so that I can eliminate. So what is 6x plus a negative 6x? That's 0x. That's what eliminates. Then I have y plus a negative 4y, which is negative 3y. And then 6 plus a negative 18, which is negative 12. So if you simplify that, that's going to give us negative 3y equals negative 12. And then I have a one-step equation. I need to divide by negative 3, and so y equals 4. I'm only halfway done because my answer is going to be x comma y. So I just found the y. Now I pick one of these equations. I usually always pick the easier one. So for me, 6x plus y equals 6 is a little easier to plug in my y. So now I know my y is 4. So I'm just plugging that in. And then I'm going to solve for x. So when I subtract 4, I get 6x equals 2. Divide by 6, x is 1/3. So now I have my solution. If I were to graph these lines, they would intersect, and the intersection is right here at 1/3, comma 4. And remember, you can plug it into both equations and it will work in both equations if it is the correct solution. Okay, let's look at a harder problem. Here we have a system, but if you notice from example 2 that the first equation is not in standard form. So that's really the first thing I want to do, is I want to get that equation in standard form. So if you need to kind of show your step here, really what you're doing is just subtracting that 5b. So we're going to have 4a minus 5b equals 3. Then that second equation, at least right now, I'm going to leave exactly the same. I'm not going to make any changes yet. So that's my first step. I've lined up my equations and put them in standard form. Now what I need to do is eliminate a variable. I could eliminate the a's or the b's, and neither looks super easy because there's not just an integer that I can multiply by one of them to be able to have terms that are opposites. So what you can do is you can always multiply by the other number. Now what do I mean by that? Look at your b's. So notice you have a 5 and a 2 when you're dealing with the b's. You have minus 5b and positive 2b. What if I multiply that first equation by 2? So I'm going to multiply everything by 2. So that gives me an 8a minus 10b equals 6. I just multiplied everything by 2. Well, how does that help me? Well, now, if I look at my b on the second equation, now I can multiply that equation by 5. Because what happens when I multiply everything by 5? That gives me a 15a plus 10b equals, and then I would do 5 times a negative 15, which is going to give me negative 75. Now, why did I pick the b's? Personally, because I already had opposite signs. One was minus 5b and the other was positive 2b. So that's typically what I will pick. You could have done the a's, and if you would have eliminated the a's, you could multiply the top by, let's say, 3, then the bottom by a negative 4. So you definitely have options. So now that I have my 2 equations, I'm just going to add those together. And so that gives me 23a. Notice the b's eliminate. They would go to positive 0b. And then I have 6 plus a negative 75, which is negative 69. And then I'm just going to keep going. I'm going to divide by 23. And I have a equals a negative 3. Now I'm only halfway done. And so I need to plug in to one of those equations. It doesn't matter which one. I'm going to choose the second one here. 3a plus 2b equals negative 15. And so I'm going to say, okay, before I even start, I'm going to put a parentheses where my a is, and I'm going to plug in a negative 3. So 3 times negative 3 is negative 9. And then I have a 2-step equation. I'm going to add 9 to both sides. So then 2b equals negative 6. Then I can divide by 2. So b happens to also be negative 3, which is really just a coincidence. So my a comma b is negative 3, negative 3. And that's my solution. If I were to graph those equations would intersect.